Hi all, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's problem. Our problem name is modular exponential for large numbers. Here the question said we have to implement par xn and we have to take the modulo of it and we have to return that, right? So in the first example, rx equal to 3 and n is 2. Here we are given m equal to 4. So 3 ki part 2 which is 9. Take the modulo with 4 which is 1. So our answer here is 1. So if you see here in the first example, we have to take 3 ki power 2 which is 9 and we have to take the modulo with 4 which is 1, right? So how we can solve this question? To solve this question, the first approach which came to my mind is simply we have to run the for loop and we just multiply it, right? If you see here, let's suppose my answer variable is 1, right? What I'm doing is I run a loop. How many times? N times. Okay. And inside this, what I'm doing is I just multiply this with x. If you see at the end, what I'm doing is I just take the modulo of it, or inside we can take the modulo of it. So if you see when I equal to 0, my answer is which is 1 into x. X is 3, right? 3 ka modulo 4 which is 3, right? My answer here is 3. When I equal to 1, my answer is 3 which is answer. X is 3, right? It's 9 ka modulo 4 which is 1, right? At the end of it we just return 1 ka modulo 4 which is 1. So this is my answer, right? But in this case my complexity is time complexity to solve this question is big of n, because we are traversing n times, right? But in the question, as you see the constraint part, we have to solve this question under log n times. How we can solve this? Let's do the dry run for log n for this case, right? So it's very simple. What I'm doing is I am passing two functions. Initially my x is 2, okay, my n is 6. Let me write here x and n, okay. So suppose this is my function where I have x and n. Now what I'm doing is, let me write here temp variable. My temp is, I just do the divide by 2, right? So I'm calling this function again, but divide n by 2, right? So if you see here, if I'm calling this function, it's divide by 2, right? Again it's calling, okay. If I divide 3 by 2, which is 1, again I am doing the same thing, which is 0. So if you see 2 ki power 0 is 1, right? And we know that any number ki power 0 is 1. So what I'm doing is, it's a base case. We have to stop here. When n equal to 0, we have to return 1 in this case, right? So in this case, it means this is my 1, this is my 1, right? Okay. Now, if you see here, I am writing temp. Let me write here temp. My temp right now is 1, right? For this, temp is 1. So as I divide by 2, it means my initial answer is temp into temp, right? So that's why I'm writing here temp is equal to temp into temp. Right now I am not taking the modulo. Okay. So if my temp is 1, 1 into 1 is 1. Now if you see, what's the 2 ki power 1 is? It's 2. Here if you see, it's odd. That's why we have to write here, if my n is odd, my temp is updated, which is temp into x. Here my temp is 1 into x, which is 2, right? My temp right now here is 2. Okay. Now we have to return this. Let me return this temp to its parent. Now this 2 is stored here, right? Here. Now if you see, we have to solve 2 ki power 3, which is, let's check manually, it's 8. Now if you see, 2 ki function of 2, 3 is going into the depth 2, 1, because we are dividing by 2, right? That's why here my temp is 2. What I'm doing is, I am doing temp into temp because we are dividing it. That's why here my output is 4, temp is 4. Okay, so we have 2 ki power 2, which is 4. This is odd. That's why we are taken here into x, which is 8, right? Now my answer here is 8. So this is return, this is 8, right? If you go further, let me update this. This is 8, right? As I divide by 2, what's my temp right now? What's my temp right now? It's temp into temp, which is 64. Is this odd? No, it's not. It's not. So what I'm doing is I simply return temp. I simply return temp, which is 8 into 8, 64. I'm returning this to the main function, which is 64. This is my answer. At the end of it, I just do the modulo of it, which is 10. What's my answer? It's 4. As simple as that. Let's do the code part. So initially what I'm doing is I am creating here temp, okay, and inside this what I'm doing, I just calling this function again and again, x n by 2. Okay, so here my x is smallest and n is also smallest. Okay, now here the base case is when n equal to 0, we have to return 1 in this case. Now I have temp. As I am dividing by 2, my actual temp is temp equals to temp modulo m into temp modulo m, right? Okay, now I have temp. If it's odd, like for example 3 divided by 2 is 1, we can solve temp into temp, but that odd we have to write explicitly, which is if n by 2 is odd, my temp is temp into x and take the mod of it. Okay, at the end we are just returning my temp, right? So this is a simple code. Let's check it's working fine or not. It should be d should be smallest. Let's check now. No matching function for call. Okay, so we have to pass m also here, my bad. Let's check now. Yeah, it's working fine. Let's submit. Yeah, as you see, all the cases are passed, right? So what's the time complexity of this solution? Time complexity is simply log n, right? Why? Because we are divide n by 2, n by 2, n by 2. How many times that recursive call is doing their work? It's log n times. So what's my complexity here? Time complexity is simply depend upon how many time my recursion call is going on. So it's n, right? Where n is my power part. X is given. We have to do the x ki power n. That n is this n, right? I hope you understand the solution and intuition. Thank you so much.